A single microscopic plug can unleash unimaginable power, rewriting the very fabric of existence. This isn't science fiction. It's the astonishing reality of nuclear fission's fundamental building block. Understanding this tiny component unlocks the secrets behind stars and the most potent energy sources. Its discovery revolutionized physics, opening doors to both incredible innovation and profound ethical questions. Imagine a world powered by forces previously only seen in exploding suns. This is the story of that pivotal discovery and its far-reaching consequences for humanity. At its core, the plug we're discussing is an atom's nucleus, specifically one that is unstable. These nuclei are not content to simply exist. They harbor immense internal energy waiting to be released. Think of it like a tightly coiled spring, brimming with potential energy ready to snap. For decades, scientists pondered the immense forces holding atomic nuclei together.
They wondered if these forces could ever be overcome to extract usable energy.
The breakthrough came when researchers realized certain heavy atoms could be persuaded to split apart. This splitting process, and in doing so, release the energy stored within its release as a structure, tremendous burst of energy. It's like breaking a large boulder into smaller pieces, and in doing so, release the energy stored within its release as a structure. The critical element is a specific type of atom, like uranium-235, which is particularly susceptible to fission. When a neutron strikes an atom of uranium-235, it absorbs it, becoming highly unstable. This unstable atom then vibrates violently, much like a plucked guitar string. Within a fraction of a second, the nucleus splits into two smaller atoms, called fission fragments. But that's not the strangest part. During this split, a significant amount of energy is released in the form of heat and radiation. Even more importantly, 2 or 3 additional neutrons are ejected from the shattered nucleus. These newly freed neutrons then go on to strike other uranium-235 atoms, continuing the each process. Falling domino knocks over the next one in sequence, where each fission event triggers more fission events. Imagine a row of dominoes falling. Continuing the each process, falling domino knocks over the next one in sequence. In a nuclear reactor, this chain reaction is carefully controlled to produce a steady stream of energy. Control rods, made of materials like cadmium, absorb excess neutrons, preventing the reaction from accelerating too quickly. This controlled release of energy heats water, producing steam that drives turbines to generate electricity. It's a remarkable feat of engineering, harnessing the power of the atom for our daily needs. Wait until you hear what comes next. However, uncontrolled chain reactions are the basis for nuclear weapons, releasing catastrophic amounts of energy instantly. The sheer destructive power released by a nuclear explosion is difficult to comprehend. Conventional the explosives by many initial blast orders of magnitude.
The initial blast creates immense heat and a shockwave that can flatten cities.
This is followed by intense radiation, which is lethal to living organisms. The legacy of this discovery is complex, offering immense potential for clean energy alongside grave dangers. It has shaped global politics and continues to be a central focus in discussions about energy and security. The ability to split the atom has led to advancements in medicine, such as cancer treatments using radiation. It also powers submarines and aircraft carriers, enabling long-duration missions without refueling. The plug, the unstable nucleus, is the key that unlocks these incredible capabilities. Its controlled application represents one of humanity's most significant scientific achievements, but the potential for misuse demands constant vigilance and responsible stewardship. And then understanding of something matter and energy was unexpected, fundamentally altered by this discovery.
The very understanding of matter and energy was fundamentally altered by this discovery.
It proved Einstein's famous equation, E=mc2, not just in theory, but in terrifying practice. The conversion of a tiny amount of mass into a vast quantity of energy is the core principle at play. This principle governs the energy output of stars, including our own sun. Nuclear power plants provide a significant portion of electricity for many countries worldwide. They offer a low-carbon alternative to fossil fuels, helping combat climate change. The efficiency of nuclear energy is astonishing compared to traditional power sources. A small amount of nuclear fuel can produce an enormous amount of electricity over its lifetime. The challenge remains in safely managing the radioactive waste produced by the process. This waste remains hazardous for thousands of years, requiring secure long-term storage solutions. Research continues into new reactor designs that are inherently safer and produce less waste. Fusion power, the process that powers stars, is another frontier being actively explored. It promises even greater energy output with fewer radioactive byproducts than fission. The journey from understanding the nucleus to harnessing its power is a testament to human curiosity. It demonstrates our relentless drive to comprehend the universe around us. The fundamental plug, the unstable atomic nucleus, continues to be a subject of intense scientific study. Its potential applications are still being discovered and refined. We stand at a pivotal moment, managing a powerful force that can either sustain or destroy. The future of energy and global security hinges on our continued responsible exploration of these atomic forces. Like this video, if you fascinating, more and incredible let us know in the scientific comments what journeys. Your curiosity fuels our exploration of the universe's most mind-bending concepts.
Like this video if you learned something new, and let us know in the comments what scientific mystery you'd like us to unravel next.